Can you guys hear me? Lower hand. You can unmute yourself so that I can hear you. Like, that's the only way I'm going to hear you. Yeah, sorry about the delay. Can you hear me? Hello? Hello? You have to unmute yourself. Or either type in the live chat. It seems like we had it going last time. I don't know why it seems like it's a little bit of a challenge today. Hello? Can you hear me? So when you log in, you want to give your device audio access. Sounds like someone's there. Someone's there? No? All right. So what I'm going to do, I'm going to see, that looks proper. Yeah, I can hear it. Okay, so my YouTube, let me turn this down because that's totally distracting. So I am live on YouTube. So we have two locations. Let me switch over to this view. Let's see, I'm gonna have to go like this. So we got a little bit of finagling that we need to do before we really get into it, because I decided to make a last minute change. And I will get everyone caught up, but I'm trying to get feedback. I'm trying to get someone to make their presence known. I didn't really want to do presentation view. I didn't really want to do all that, but I totally get it. I mean, it's fine. I'll let it be. So again, I'm not sure that if you guys can hear me or not. Okay. You have to give us permission. Oh, I see. That's what it is. Okay. I totally forgot about that. That's what happened last time too. That's right. All right. So if I go here, session settings, share audio, video, chat messages, draw on the whiteboard and files. Okay. You're totally right about that. I only show profile pics. That's probably best. Okay. So try it now. Can you all can you log in? Can you? Yeah, there it is. Okay, yeah. Yeah, it's fine. Yeah, so the delay so the delay came because I just I had to shut down with my last class. Like there's no time. I get 5 minutes between classes. So I'm ending the live session. I'm ending a live session, then I'm going back and I'm trying to update so I have the right title and information for you all, changing thumbnails and stuff like that. And so I totally forgot about changing those settings. I don't know if I can make it default or not. So we got a few things that we kind of need to talk about to kind of get caught up. Let's start by taking attendance. Now I can see a list. So now the first thing is we are actually in two locations. The first point of contact is Collaborate. We more than likely would do most of our communicating on YouTube, because I think that let me think about it. Give me a moment. Yeah, let's just stick with YouTube, because for calculus, we're going to have to be doing a lot of writing, a lot of drawing. So we're just going to do most of our communicating on YouTube. I'll try to do a primer though, because YouTube has a delay. So it's I'll try to give a heads up, and whenever I get the heads up, we do have to kind of jump back over to Collaborate and use the audio so that way we can talk live. Whenever you turn on your audio on Collaborate, only use your last name. So I'm doing my best to kind of protect, personal information. So you would say, hi, this is Mr. Johnson or Miss Okonkwo, but just use your last name, right?
We all know each other.
No. I'm just saying for the sake of privacy's sake on YouTube. You know what I mean? And because a lot of times I'm not going to be on the screen, and so I'm only going to be listening. And so just announce yourself. Say, hey, this is honestly for me, but I'm still trying to protect everybody's privacy.
You can put your own screen on Collaborate. So instead of you, we can see your screen, and through Collaborate, we can ask you questions. Because on YouTube, it's like the delay.
Yeah. I mean, yeah. I'll keep it. Well, actually, I probably need to change it around a bit. But I'm doing Collaborate on my iPad, and I'm also working on my iPad. So the audio, like that's what I'm saying. Announce yourself as far as your last name, Mr. or Mrs., and then your last name. But I'm going to be working on my iPad, so I probably should do the Collaborate on my laptop. I got to figure out that setting a little bit later. What's the other thing? But I am monitoring the chats. So I have like one window monitoring my YouTube chat. That's how someone reminded me. I was like, well, that's right. I got to update the settings. I'm also listening, so you can actually just go back to Collaborate. And the Collaborate is good for a live audio chat back and forth, right? So it's like there's no delay when you're on Collaborate. But I need to be sharing my screen, so that's why we have to do most of the instruction on YouTube. Okay, so the first order of business for the day, let me go ahead and take attendance. So we got started a little bit late. That was my fault, but I'm going to go ahead and take attendance now. Time is about 1:45, so, we'll just let me pause. So on YouTube, what I'm going to do, I'm going to mute my audio on YouTube, so that way when I call names, it's not being broadcast. like this. Okay, so on YouTube we're back. We're gonna keep this discussion going and collaborate for right now. I know I have so on YouTube I have a waiting room displayed right now. So if you're in the collaborate session, you can go ahead and at least log into the waiting room, but we're going to continue the discussion and collaborate for right now. So one thing I decided, because I know we have like Cengage and I know I have what's on Moodle, I'm probably going to change the books. So just kind of being just kind of, you had to kind of sit back and kind of listen. I went on and made a request. We're actually able, because we're all being forced to go online, we can actually get complimentary full access to these sites. And so instead of doing Cengage, that publisher, I'm just not versed in Cengage at all. And I'm going to waste a lot of energy trying to figure out how to post assignments and all this stuff. So what I'm going to do, I'm actually going to switch publishers and get access for Pearson for calculus. So what I'll do is I'll find assignments. All our work is going to be on Pearson. I'm going to try to match the topics as best I can and as simply as I can from Pearson, whatever's listed on Moodle. I'll post homework that parallels it, if that makes any sense. So, but all you're going to be responsible for is logging into Pearson. I'll get you an access code so that you can get full access. So no more this quarter, we don't have to do that every 2 weeks, create a new account, all that jazz. We don't have to do that this go around. Let me go like this and see if I can get this working. We don't have to do that this go. So because of I know, right? I know, because I know how much of a challenge that was. I know. But we have access to what we have access to, and so we will and do, and we do what we need to do, and we keep it moving. If we can't find resources to get approval for stuff, then we just find another way. To me, that's the mark of the mathematician. That's my personal mark. Like, I know I'm resourceful. I don't be having anything, but when something needs to get done, I'm going to find a way to get it done. Like, that's just my nature. I can't stop thinking about it until I figure it out. But that's how a mathematician is. Pearson's the go. Yes, I agree. It is definitely the greatest of all time. So I'm just going to make an executive decision and go ahead and switch our materials over to Pearson. I'm just familiar with that platform. I know exactly what to do, when I need to do it. I don't have to waste time trying to figure it out. So you're going to have to just kind of bear with me for the next 24 to 48 hours. I should be able to get you all access codes and get you all. But what you can do right now, so this is the other thing we need to talk about. So what you can do right now, I'm going to go ahead and load a PDF on how to register. You can go ahead and actually register for our Pearson account and go ahead and start the 14-day temporary access so you can get started on any work that I post. So while we're talking, let me just go ahead and do that right now. I'm going to go ahead and share this certain file. So let me go back here. Let's see, it is this one. I should be able to get access codes for this. Actually, I need to go back, allow, but let's go back to the courses, skip for now, go back. And if you have questions, just stop me, all right? So that's why I started in Collaborate. Just unmute yourself and say, hey, Mr. Pfeiffer, I got a question, blah, 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 blah. I'm gonna go here and I want to get registration instructions. I wanna share this. So the first place I'm going to put it in our box folder. I'm going to go to all files. This is Spring. This is Cal 1, course files. I'm going to put this into the handout section. Yeah, I'm going to put it there. So I'm uploading registration instructions, and also I'm going to go ahead and load it into this Collaborate session. So if I come back to Collaborate, which is here, and I'm going to share this file. So I'm going to load instructions on how to register for Pearson. So, at your leisure, go ahead and follow the instructions. Let me get it loaded first. Let's go to browse. This is in box. Let's go Spring, calculus, files into the handouts. How to register this one, right? It's uploading. And let me turn this down some more. I feel like that doesn't need to be so loud. Hello. And I'm gonna turn this up just a little bit. Hello. Okay, and I want to share this now. Okay, so you should be able to, hopefully you can download this file. If you can't download it, there is a link in Pearson, in our box folder. But honestly, if you go to Pearson, You can see the course ID right there. It says the Pfeiffer 72673. That's the course ID. When you're prompted for an access code, on the previous page, as a link that says get the 14 days temporary access, just go ahead and sign up for the temporary access. So with that being said, let me go ahead and create some assignments. We are in section, is it 1? Where did I load it? I have it loaded. Where do I have it loaded? Chapter 1. Yeah. We're going to be in chapter 1. So, where did I leave off? Let's go to Pearson. I'm going to go ahead and load some assignments. So at least like maybe the first half of chapter 1. All right. Sign in. Skip for now. So give me just a moment. I'm kind of doing some of this stuff on the fly, but I don't want to delay as far as making things available. I want to give you time. So let me just give me a moment to kind of get this assigned. And actually, I think I need to go over to Chrome. All right. Yes, let's log in. Come on. I'm watching the clock. We're going to go to Pearson. Come on. I must have clicked something wrong. Let's try that again. Here. Sign in. Oh, what's good? It's not allowing cookies. You know what? So let me just close all this out. Like this, close all, go here. We're going to do a new page. Let's go to Pearson. Sign in. Come on. Here. This one. Sign in. All right, let's go to calculus. And let me just load assignments for chapter 1. That's fine. I'll have to fix that later. I'm gonna go to manage. Can you all still hear me okay?
Yeah.
Okay.
Yeah.
So I'm gonna assign this one. Let me see. In chapter 1, there's only 4 sections. Today we're gonna be doing 1, 2. So I might load. I'll load all of chapter 1. I'm just gonna assign it for right now. I'm gonna come back and change some settings. So the work that's loaded, that all like each week, those assignments are due every Saturday by 11:59 p.m. As faculty, that's just what was agreed upon. So I went on and loaded chapter 1 assignment. I haven't set the due date for it, but today what I'd like to do is go through section 1.2. I know section 1.1 was a different book. If I need to do a lecture there, we will, but we shouldn't need to. I'm going to go ahead and start today with section 1.2 from this new book. It should parallel what we're doing. I don't want this assigned. Let me unassign this. Let me unassign this. Oh, it's not assigned right now, but it's fine. I still want it unassigned. I'll fix all that later. Okay. So if I go to view, cool. So chapter 1 is loaded. I'm not going to worry about that right now. I'm going to go here. I want to go to resources, PowerPoint lecture slides, chapter 1.1. Not 1.1, sorry. Let's go to 1.2 for today. Let me glance at it. Can I glance at it? Figure, snapshot of a traveling wave packet. Figure, these are figures. See, I'm not liking this at all. Figure, it's no explanation. Figure, what is this? This is no good. Summary, transformations. Let me get out of this. Let me go back. Interactive figures from the textbook. That's the one I just did. Give me just a moment. I'm kind of making a decision. View interactive figures. Okay, that's the entire chapter. Okay, we'll do the best we can with section 1.2. So what I'm probably going to do, we'll go through these slides. Nope. Oh, let's go here. We'll go through the slides. It might be a little bit funky, but we'll kind of take some time to kind of just get practice. I think it'll make more sense if we just work through examples. I really wanted a bunch of examples, but they're not really showing. So we'll do the best we can with the PowerPoint, and then from there we'll just take the rest of the class to kind of get some practice on the question on the homework set. And I think actually going through the homework will make a lot more sense, and I could explain that a lot better than these slides. But let's just take a moment to look at the slides. Does that make sense? Is that okay with everybody? Okay. So let's share this. Yeah, let me just be consistent. Let's print. Open in another. Come on. Notability. I'm just going to create a new note. I'm going to update the title later. Import. Okay. So, what's the best place to do this? It is in presentation view. Let's see. Let's stay in collaborate. Let me see. So let's go here. I want to save a copy. Here it is. Save a copy. I want to go to box. Number 10. Here it is. Spring. Calculus. Come on. Course. We're almost there. Notes. And I want to save it for the PowerPoint lecture slides. Save it right there. Okay, so I think for these slides, I kind of glanced at them. I think they'll be a better presentation in Collaborate. So we're going to stay in Collaborate for right now. So I'm going to go back there. I'll load the slides in Collaborate. That way we can kind of have a live discussion, and it won't be that delay. It's not, I don't really like the slides, but we'll do the best we can with the slides. But my real goal, I want to take as much time to kind of just start on some of the homework. And I think that'll be a better explanation as far as some of the stuff. Let me go to browse. Box. This one. This one. This one. Notes. PowerPoint lecture slides. And let me get this one. Okay. And come on. Converting. Okay. So let's just take a little bit of time. Let me see. If the time is 2, we got about 50 minutes remaining. I don't really want to take a lot of time on these slides because I really would just like to work some examples. I think that's okay. So on YouTube, I'm going to go ahead and share. So, all right, cool. That's fine. I'm not going to worry about that. So now as we kind of go through these slides, you know, so we all should be in Collaborate right now. And just stop me, you know, if you have a question. It should be live. There should be no delay. And then we'll just do the best we can with these slides. But I really would like to get to the homework set. So like I said, we have about 50 minutes remaining. So we'll take some time and see what it's looking like. Something just lost power, and I have no idea what that was. Are you guys still there? Can you see me okay? Yeah. Okay.
Yeah.
All right, so let's take a look at this. So last time we talked about 4 ways to represent a function. So that was a different text. We're going to switch over to this text and just give it a go. It's a Pearson text. So I definitely like the Pearson platform. I know how to operate that without any thought. So that's why I'm doing this. And especially since we can get full access. So we're just going to pick up here and look at representing a function. This might match the last one, but it shouldn't be too bad. Let's see. So algebraic functions. So these are like Venn diagrams. Algebraic functions are functions like rational functions and polynomials. Rational functions are functions where we have fractions, and I want to say the variable you have variable either in the numerator or the denominator of the fraction. Polynomial is going to be a finite sum of monomials. A monomial is going to be something that's like, it's going to take on the form, you have a real number times a variable to an integer, a non-negative integer exponent, right? So it's going to be something like 3x squared. That's a monomial. And a polynomial is just a finite sum of monomials, right? Versus a transcendental function are going to be like, okay, we have exponential functions, trig functions, log functions, and there are others. So we have algebraic functions versus transcendental functions. So, and stop me if I need to write or re-explain or revisit any of these notions or ideas. Let me see. So on the left, it looks like we have a snapshot of a traveling wave packet. Okay, I would imagine that would be a transcendental function. Wave fraction. I don't really know what they were getting at with that. I'm gonna let that be. On the right, we have the probability of getting at least a double 6 after n throws. So that's like probability. But notice that looks like what? Kind of like a log function almost. That looks like a log function. I'm gonna let those be for right now. So look, notice we have the y-intercept. We have a y-intercept here. So we have these two graphs, right? So let me see some things to kind of remember. So from like college algebra, you know, we have like the equation of a line is y equals mx plus b. What do we mean by the y-intercept? What does that mean? Anybody there? Hello? Hello? No? You guys left? Okay.
The x-axis for that?
So wait. Are you guys watching on? Are you watching on YouTube or on Collaborate?
I'm on Collaborate.
Yeah. Okay. So yeah, you know, I'll just. So yeah, what do we mean by that? Like the y-intercept versus the x-intercept and stuff like that. Okay, that was a question.
The value of y when x is 0, I think.
Yeah, that's how to find it, right? So if we want to talk about how to find a y-intercept, we set x is 0. The y-intercept is where a graph crosses the y-axis. X-intercept is where the graph crosses the x-axis. To find the x-intercept, we set y to 0 and solve. To find the y-intercept, we set x to 0 and solve. Say we have, look at these, we have these two lines. Where is the solution to the system for these lines? Like there's a solution that's going to work in both lines. Where's that solution going to occur? Where's the solution going to occur for these lines? Where the lines do what now?
Intersect.
Where the lines intersect, correct? Let me remove my camera. So the lines cross, that's fine. Right here, right? So the solution for the system is going to be where the lines cross. Can I just erase part of it? Anyway, we'll let that be. So I can't think of anything else here. I think, you know, we should be okay with this kind of notion right now. This one, we're expressing the demand function as based on, I think it's the price. So what I think this slide is saying is that, like, okay, we have this demand function and it's based on the price. What can we notice if we think about supply and demand? Like, for instance, as the price goes up, what can you infer about the demand? As the more expensive something becomes, does it become a greater demand or a less of a demand?
Less of a demand, so it's
inversely proportional. As one thing goes up, the other thing goes down, and vice versa. Is that do we agree with that? Is that okay? All right. Let me get that caught up and let that be. Okay. Yeah, I can't really see anything there, so I'm gonna let that be as well. This is an example of a piecewise defined function. A piecewise defined function is just multiple graphs on the same plane. Okay. I can't really see anything here, so I'm gonna just kind of let that be. Okay, so notice with this one, right? So we have this piecewise defined function. On the top, we have x squared minus 5x plus 6 divided by x minus 2, as long as x is not equal to 2. And then otherwise, when x is equal to 2, then we put 1. How did they get that graph? Notice that most of the graph is just a straight line, but when we look at the piecewise defined function, we have this x squared minus 5x plus 6 divided by the x minus 2. Why do you think that they're getting a line like that? What do you think is going on there? Can anybody chime in there? What did they see, or how did they think they're getting this result? Like, can anybody explain, like, why is most of this graph a straight line?
Can't you simplify it to y equals mx plus b?
So, yeah, we can simplify it, right? So we have this, like, x squared minus 5x plus 6. Can we factor that? Like, the x squared minus 5x plus 6. Can that be factored? You know what I mean by factored?
Yes, to x minus parentheses x minus 2 plus parentheses times open parentheses x minus 3.
What is it? X minus 2 times x minus 3? Right? So the top, it looks like the top, let me see. I'll go, stop that. Why are you doing that? There we go. So the top looks like it can be rewritten as, I heard, x minus 2 times x minus 3. Okay, and then the bottom is x minus 2. When we identify the domain, we identify the domain from the original, so that means that x cannot be 2. Why is it that x cannot be 2 from the original?
X can't be 2 because if you plug it in, there would be a 0 in the denominator.
Right, we can't divide by 0, so that's why x can't be 2 from that original part. But then after we simplify, we're going to finish with basically y equals x minus 3. Notice it has a slope of 1, the y-intercept is negative 3, and it's just not defined when x is equal to 2. So then this piecewise function says, okay, well, if x is equal to 2, just put 1. All right, so that's what's going on with this slide. So this is an example. So that was just like some of the backstory on this image. Yeah, I'm going to let that be. Let's see. So again, I'm just kind of describing, when I see these images, I'm just kind of describing what I see. Can somebody describe to me what function is this that's showing? What's this one called? Begins with an A.
Absolute value.
And what does absolute value mean? Like, what is absolute value? So for instance, if we do the absolute value of 3, what's the absolute value of 3? What's the absolute value of 7?
7.
What's the absolute value of negative?
Number is from 0, right?
The positive distance, right? So if we did the absolute value of negative 5.
It's 5.
Right, so absolute value is the positive distance a number is from 0. The graph of absolute value looks like this. It's a V-shaped graph. Notice it has a sharp edge or sharp corner, right? So, you know, I'm just going to kind of let that be for right now. These are what's called power functions, right? Let me see. Power? Yeah, I think these are called power functions. It's just like a variable x to some power. So like on the black one you see is y equals x squared. And then we have y equals x to the power of 4, or then y equals x to the power of 6. As we increase the power, what do you notice about the graph? What do you notice about our graphs?
You get steeper.
Yeah, they get like more narrow, right? As the power function increases, they're becoming more narrow. Notice that all of these exponents, all of these powers are even, right? So the highest powers, in this case, they're all even. Notice they go in the same direction. Okay, I just want to bring that to your attention. Notice here, if the last one, all the exponents were even, what difference do you notice with this slide? All the exponents are what?
Odd.
So with these power functions, the exponents are odd. Notice as the odd exponent gets higher, we still kind of get that more narrow effect. But what's the main difference that we notice between an even power function and an odd power function? With the odd power function, what do we notice? What's the main difference? Like with the even function on this previous slide.
Go with an odd behavior graph.
like if we talk about the in-graph behavior, did the left and right, did they go in the same direction or opposite directions?
Same direction.
They went to the same direction when the power function was even. When the power function has an odd exponent, what happens with the in-graph behavior? Did they go in the same direction or opposite directions?
They go opposite.
They went in opposite direction. That's a very key thing. So that's a property so with that, we can get a sense of the in-graph behavior or the long-term behavior with these power functions, okay? So I know it's a little bit abstract. You just kind of have to let it be. I'm really trying to make my way over to the homework, but I want to kind of touch on these. So now we have a variable to the power of a fraction where the denominator of the fraction has an even denominator, right? So like if we say x to the power of a half, that's really the graph of what function that we've talked about, that you've seen in the past. X to the power of a half is really the graph of what function? Does anybody know that one? So x to the power of half is actually the graph of square root of x. X to the power of 1/4 is actually the graph of the fourth root of x. X to the power of a 6 is actually the graph of this sixth root of x, right? So on and so on. So when we do an even root, notice it kind of is like the top half of a sideways parabola. That's what the image looks like. Versus if we have an odd root, or index, should I say, an odd denominator, notice it has like that S kind of pattern. Not only do we have the top half of a sideways parabola, but we have the other side going on as well, right? So I just wanted to kind of make a distinction between the previous slide and this slide. Let me see. So this is a rational function. I know that in my classes we haven't exclusively gone through graphing this. If these arise, I will take some time to kind of walk through how to graph these things. Otherwise, as you kind of go, so we're doing things remotely. So, you know, you can use things like you have graphing calculators. You can use GeoGebra. Do whatever you kind of need to do to kind of get it done. But if needed, we can take time and I can walk you through how to graph a rational equation. It's a little bit bulky and cumbersome, but it's about anywhere from like a 4 to 6 step process. And it definitely takes practice. But if you need to, we can walk through how to graph a rational function. I'm not going to do that right now, but you know, we can do it separate. Another way to kind of get a sense of a function is you can make a table. So we have our set of input values, our x values, and our set of output values, or our y values. The more points we have, the better our graph will be. So if we plot those ordered pairs, you know, we can get a sense of how the function is behaving. So, you know, with this whole discussion, we're just looking at different ways that graphs can be presented, and we can kind of interpret and things of that nature. I can't think of anything to say here. I'm just going to kind of let this one be. This is also like a piecewise function, right? So the first line tells you what to do if x is less than 1. The second line tells you the graph if x is between 1 and 2. The third line tells us what kind of graph if x is strictly greater than 2. Stop me if you have any questions. Like I said, I'm trying to make my way over to the homework. We have right at about 30 minutes remaining. This is another piecewise function. I'm going to let that be. I'm going to let this be. So I'm not seeing anything immediate there. That's still another. I'm going to let that be. Oh, so this one is about transformations, right? Where the black graph is the original graph. So from college algebra, can anybody explain to me, say we add like +3 on the outside of our basic function, how does that affect the graph? Versus subtracting a +2 on the outside of our basic function, how does that affect the graph? So can someone explain to me, if we add a positive on the outside, how does that affect the graph? If we
shifts the graph up, and if it's subtracting the number, it shifts it down.
Essentially, that's how that goes, right? If we add a positive on the outside, it moves it up that many number of units. If we subtract a positive on the outside, it moves it down that many number of units, right? So if we can do these manipulations inside, can anybody remember, say we add a positive, if these are the manipulations on the outside, suppose we added a +3 on the inside, how does that affect the graph?
If it's a positive on inside parentheses, it moves to the left, and if it's
Right.
negative, it moves to the right.
Right, so the inside was always the reverse of our intuition. Let's see if that comes up next. Right, so in this example, the black is the original. Notice with the red one, we added a positive on the inside. It did the reverse. Even though positive x goes to the right, inside manipulations from college algebra does the reverse of our intuition. So, -3 is what makes that 0, so we actually moved it to the left by a factor of 3. If we subtract a positive 2 on the inside, that means a positive 2 makes it 0 on the inside, so we actually move that one to the right by a factor of 2, right? So inside manipulations were typically the reverse of our intuition, okay? Let me see what's next. So if the black is the original, this one is about if we multiply the outside. So the red is if we multiply the outside of our function by a number larger than 1. What kind of change is that? If we multiply the outside by a number larger than 1, what kind of change is that? Can anybody remember that articulation?
If it's larger than 1, it shrinks, and if it's less than 1, it spreads, or the opposite. I don't remember.
So if we multiply the outside by a number larger than 1, outside manipulations are going to be vertical manipulations. If we multiply the outside by a number larger than 1, it's going to cause a vertical stretch. So a vertical stretch means it's going to get tall and skinny. Versus if we multiply the outside by a number between 0 and 1, that's going to be a vertical shrink. So it's going to be smushed in a vertical sense. So outside manipulations are vertical manipulations. This is all from college algebra, right? So I'm pretty sure that these transformations are going to pop up as we kind of navigate through. Have y'all met my TA? Did y'all meet my TA last time? She's kind of wheezing, so she probably was eating stuff that she ain't had no business eating. Come on. There you go. So this is our official TA. This is Malachite. So she'll be periodically checking in on us, making sure that we're okay, we're safe and sound and protected. Okay, say hi, Malachite. All right. I was trying to not show my hand. Anyway, but that's Malachite. She's our TA. She'll be popping in every now and then. I kind of try to keep her here to keep her calm, because sometimes when she's on her own, she'll lose her mind, and then she'll be a huge distraction. So at least when she's here, she's less likely to go crazy. So yeah, outside manipulations are vertical, and they follow our intuition. So if we multiply by a number larger than 1, we can anticipate a vertical stretch. If we multiply by a number between 0 and 1, it's going to be a vertical compression. So if outside manipulations are vertical manipulations, what do you think could describe a inside manipulation? It's going to be what? So if outside means vertical, inside should mean what? Horizontal, right? So suppose we multiply the inside by a number larger than 1. What do you think is going to happen if you had to guess? So if we multiply the outside by a number larger than 1, it causes a vertical stretch. If we multiply the inside by a number larger than 1, what do you think happens? So instead of it being a horizontal stretch, it's actually going to be a horizontal compression. It's kind of the reverse. Inside manipulations are horizontal, and it's the reverse of our intuition. So let's see if we can see it. So if we multiply, they did a couple of things going on here. This is actually a negative. Oh, that's still outside. So in this one, they actually are multiplying by negatives, right? So if we multiply the outside by a negative, it's going to flip it vertically. In this example, now notice, the black is the original. If we multiply the inside by a number larger than 1, instead of being a horizontal stretch, it's actually a horizontal compression. And then the inside by a number between 0 and 1 is a horizontal stretch. Okay, so this is all recap from college algebra. If we multiply the inside by a negative, it flips it horizontally. Okay, I'm going to let that be. Oh, so then everyone wants to list the transformations. What's the time? I want to actually hop over to the homework. Okay, so I'm gonna. Those were actually examples, but I'm gonna let those be. So what I'm gonna do, I think we. So I think we have to go to the YouTube because I need to share my screen. Okay, and I don't know how to share my screen on Collaborate. So we're gonna have to hop over to YouTube. There will be a little bit of a delay, but what we're gonna do is kind of work through some of the homework set for 1-2. We didn't get as much time as I would have liked, but we can take 25 minutes to kind of go through the homework. Actually, what I think might be a better use of our time, we have 25 minutes remaining. Let me just let you all, let's just take that time to go ahead and log into Pearson. So what you want to do is go over to Pearson, and I'll include the course ID. So I'm going to go like this. I'll include the course ID in the chat so that you don't have to search for it. Go to Pearson, and you can actually log into any account. You can use any account that you want, honestly, because you're not gonna have to do multiple accounts. And let me go ahead and I'm gonna load the this one. I'm gonna load the course ID. So the goal for the rest of the class is go ahead and log into Pearson, and let's get access to this course. And the course ID, if I go to the chat window, is right here. So the course ID is this. Oh, not there. So again, we only have about 25 minutes remaining. The course ID, no. 72673. And I should be able to get everybody full access before the weekend is out, because I was kind of going back and forth with the rep. He was actually fast yesterday, but I decided after that to go ahead and switch over my calculus as well, just for simplicity. So I got to check my email to see if he gave me an access code or not. Okay. So again, for the rest of class, I'm just here to kind of answer questions. I want you to log into Pearson. Let's go ahead and get registered and go ahead and get the temporary access. I'm going to check my email to see if I have access codes that I can share with you all, and then that way we can go ahead and get our full access. And I'm really here just to answer questions. I went on and loaded, I think, chapter 1's notes and homework for chapter 1. I will also probably load a quiz, and let's be ready for exam 1 next Friday over chapter 1. All right, it should be really light. It's just a review. Okay, so I'm here for questions if anything is not clear. And the session from Wednesday, it is on my YouTube channel as well. So I'm just gonna kind of quiet down for a bit, and I'm just here to kind of answer questions. But I want you to go ahead and log into Pearson and see, can you get started on that homework and ask questions. And while you all work there, I'm going to check and see if I got an access code in my email or not. Hey Google, play some study music.
Sure, check out the study music station on YouTube Music.
Let's see. Let's go here. Yeah, I have to call him back. Week 1. Egypt, collaborate. Can we hear you on Collaborate? Yeah, that was my fault. How to attend, missed call. James. Communication, graduations. Dang, that's going to be deep. Oh, is this for Cengage? I didn't really want Cengage.
Do we wait for the access code or just get temporary access?
Yeah, just go ahead and do the temporary access for right now. Once I get an access code, then, we'll get that going. Swanson, I think I replied. Let me try to call him. Let me see if I can call him. Let me not announce that. And again, I'm just here if you have questions. Oh, she called this morning? Let me see. Hi, greetings, Mr. Swanson. This is Mr. Pfeiffer. We were going back and forth via email. I decided to go ahead and do my calculus course via Pearson as well. I'm not able to leave my cell phone right now because I'm actually live on the web right now. And I think I sent an email. I was just trying to follow up to see could I actually get full access codes for this calculus course as well. I'll just be looking out for your response via email, or I think my cell phone or whatever. My contact number is there as well. But otherwise, thanks, and I will catch you a little bit later. Take care. See ya. All right, but yeah, you should be able to go ahead and get temporary access, and we'll get you full access definitely by the start of next week. But you should be able to work through the weekend, and we'll get that going for everybody. What's the time? Yeah, we only got about like 20 minutes remaining. Yeah. Okay, I have to respond to these later. Okay, are you all okay? Did you have any questions about anything?
Is the homework already loaded for tomorrow?
Today is what, Friday? I'm open to providing an extension for that. Let's go ahead and have 1-1 and 1-2. Let's have that ready for tomorrow, though. It shouldn't take long, because we need it because we had to submit starfish reports, so we need something. I'm gonna make 1-1 and 1-2 and the quiz for this week based on 1-1 and 1-2. I'm gonna make that due tomorrow by midnight. So that'll be my goal before the end of the day, if that makes any sense. I figured out what lost power is my AirPod. I was listening to my YouTube channel earlier. Did that answer your question, though?
Yeah.
Okay. So I'm just here for the next 20 minutes or so. I guess you're fine there. Ooh. So while you all work, I'm going to do the same thing. And if you have questions, I can load it and share it and things of that nature. So I'm going to go to Pearson. Not there. Let's go here. Let's get rid of this. Let's go here. First, let me put this in order. Manage the course. So I want this to be there. Okay, so then let's go to manage. We're going to edit. Nope. Stop. Can we stop? Cancel. Hey Google, stop the music. Relax. I know you hear stuff. Just relax. It's okay. Stop. It's okay. I know you're ready. Just stop. Thanks. It's okay. Final submission. 16. 20%. Okay, so what we can do, we have about 10 minutes remaining. We'll just do a quick check-in for each person. Like once you're able to log into Pearson and I confirm that I have you on my roster, we'll call it a day. So, whenever you're ready, you can say, hey, I'm in Pearson, and we'll just do a quick check-in, see if you have any questions, and then I'll let you go one by one. Anybody would like to go first?
I'm in Pearson already.
And we're speaking with who now? Your last name? Pardon?
Acevedo.
Miss Acevedo. Let me look at my roster. I'm not showing anything there. Let me see. I just want to manage. Okay, Miss Acevedo, I see you. Did you have any questions?
No.
Okay. All right, Miss Acevedo, have a good weekend. We'll be back. So for Monday, basically, we'll be here at the time. You just want to log into Collaborate, and I usually provide a live YouTube chat. Yeah, and let's go ahead and be ready for exam 1. Just chapter 1 should be enough for right now, and I'll kind of be doing updates and be in communication over the weekend. Okay, have a good weekend. Who'd like to go next?
I'll go next.
What's your last name?
Johnson.
Mr. Johnson, I see you on my roster. Did you have any questions?
Are you gonna upload PowerPoints to Moodle?
That is a good question. They are. I will upload them to Moodle. They should be available on our box link right now, but I will get them in Moodle. Okay. Who's next?
Happiness.
Miss Happiness. Did you? I see you on my roster. Did you have any questions?
No.
Okay. Have a good weekend. Who's
too.
next? Thanks. Yep. Who's next? Uh-oh.
Edwards.
Oh, Miss Edwards. Okay. I see you on my roster. Did you have any questions?
I don't think so.
Okay, so I'm available if you do. Just email me and, we can go back and forth. Otherwise, have a good weekend. Okay. Stay safe. Yep. Who else? I think we have like 2 more, I think. Anybody?
I'm Pearson.
What's your last name?
Hopkins.
Miss Hopkins, I see you on my roster. Did you have any questions?
When is the test?
So, okay. So every week we can anticipate either a quiz or an exam. This week I will load a quiz. The quiz will be due this Saturday, so basically tomorrow by 11:59 p.m. And then next week, so our exams are basically going to be weeks 2, 4, 6, and 8, essentially. Those are when I'd like to do exams. So it's basically like an exam every other week and a quiz every other week, if that makes any sense. Yeah. Yeah. So exam 1 is next Friday, and it'll be due that Saturday. Okay. I think we have one more. Are you there? I think we're still missing one. So I'm not going to worry about that. I'm going to wait a couple of more minutes. All right. Okay. So I have been streaming on YouTube. So let me just kind of switch back to kind of like this kind of view. We didn't really use that, so I'm not going to worry about that too much. Let me just add a page, not that one. Okay. So we're gonna actually end that session. So this session, because we had very little time and we actually started really late, it was just like technical difficulty, switching from one course to another. That's just how it goes sometimes. It was a lot smoother, but it is what it is. So at least had a lot of audio. We didn't really write too much. We just kind of had like a discussion. And we're still kind of getting things set up. I decided to do a last minute judgment call since that we can get full access codes as a result of everything. I decided to just go ahead and shift it over to Pearson. And we'll do the best that we can, because that way I'm not wasting time trying to figure out how to use Cengage or whatever. Otherwise I would have did it, but just for the sake of time and consistency and fluidity, I went on and just signed up for a Pearson account. So I'm trying to get full access. Otherwise, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your weekend. Okay? Take care. Peace. Stop.